teeming with life, whose existence is dependent on complex interrelationships, the rainforest thrives in a definitive balance of symbiosis. The ecosystem of the rainforest plays a critical role in the health and well-being of our planet Earth. And to sustain those beneficial effects, the balance in the ecosystem must be maintained. The complex balance of life in the rainforest is not unlike the ecosystem that exists in the rumen of the dairy cow, where hundreds of different species of bacteria, protozoa, and fungi coexist in ecological equilibrium. In the unique symbiotic relationship between cow and rumen microbes, the cow supplies the environment and food for the microbial population, which in turn digests those feedstuffs to provide the cow with essential nutrients in the form of microbial protein and organic acid energy sources. Let's go inside the rumen to get a microscopic view of this microbial ecosystem. The microbial population consists of an interacting complex of bacteria, protozoa, and fungi, and their numbers are enormous. The microorganisms living in the contents of a single dairy cow's rumen easily outnumber the total population of people living on Earth. Bacteria make up the largest number and diversity of population in this microbial world. They function as processors of fibers, starches, sugars, acids, and proteins, to furnish useful compounds and elements necessary to fuel both growth and productivity in the cow. The role of protozoa and fungi is less clear. However, these microorganisms do provide functional significance in the digestion of feed. The rumen environment is a frenzy of digestion and fermentation. Microbes attack feed particles in the rumen, secreting digestive enzymes to break down complex molecular structures into simpler components. These simple molecules are then absorbed by microbes and metabolized for use as energy in reproduction. During that process, microbes produce metabolic waste byproducts, which are excreted back into the rumen fluid, absorbed by the cow, and utilized as an energy source. The dairy cow depends on bacterial proteins and the acids produced by bacterial digestion for more than 80% of her nutrition. The primary byproducts of rumen microbial activity are volatile fatty acids, or VFAs. The most important VFAs for productivity and growth include acetate, propionate, and butyrate. When fiber is fermented, acetate and butyrate are the primary acids produced in the rumen. Acetate and butyrate are lipogenic precursors and tend to support butterfat synthesis, which is the reason digestible fiber levels in the diet are key when butterfat production is important. When the diet contains large quantities of starch, propionate production becomes more significant. Propionate is glucogenic in nature and is the primary energy intermediate for lactose production, which is critical for higher milk yields. Another result of feeding a diet rich in starch is the production of considerable quantities of lactate. Lactate is much less useful to the cow than propionate, and in fact is the primary culprit in metabolic problems like acidosis. As we feed the cow increasingly large quantities of starch, as opposed to a diet of slowly digesting fibers of forage, an ecological balance is much harder to maintain. As rapidly fermenting starches are ingested by the starch-digesting bacteria, such as Streptococcus bovis, the buildup of acid results in an imbalance in the rumen ecosystem. The acid-sensitive fiber-digesting bacteria are replaced by acid-tolerant starch digesters. This condition interferes with the numbers and effectiveness of the overall bacteria populations, and as lactate accumulates in the rumen, it causes a decrease in rumen pH to a very acidic level of less than 5.5. Nature designed the rumen to allow ruminant animals, like the dairy cow, to survive, grow, and reproduce on the native grasses of the prairies and savannas of the world. In modern dairy production, up to 100% of the cow's diet is chosen for her. The use of grain-based diets has increased productivity and improved economic return. However, a more energy-dense diet can cause problems for rumen microorganisms and change the rumen pH and ecology. Maintaining the rumen ecosystem is a balancing act. Rumen pH is one of the most variable factors influencing microbial population and levels of volatile fatty acids produced. Certain bacterial functions are optimized at different pH levels. Fiber-digesting cellulolytic bacteria are most active at a pH of 6.2 to 6.8, but populations of cellulolytic bacteria can be reduced when the pH falls below 6.0, whereas starch-digesting bacteria thrive in pH of 5.2 to 6.0 or a more acidic environment. To accommodate all these needs, normal feeding practices should maintain a pH range between 5.8 to 6.4. There are several management practices we can follow to help maintain the delicate balance of the rumen ecosystem. One is to encourage the production of saliva. Long-stem forages stimulate saliva production, and by swallowing large quantities of saliva with the cud, the cow naturally buffers the rumen by recycling sodium bicarbonate into the rumen. Additional buffers can also be added to the diet to increase rumen buffer capacity and reduce the detrimental effect on the pH-sensitive bacteria such as fiber digesters. Another management practice to help assure that bacteria are nurtured properly is the addition of rumen enhancers to the cow's diet. Feeding yeast culture can help stimulate production of both fiber-digesting and lactic acid-utilizing bacteria. Yeast culture provides essential growth factors which enhance bacterial reproduction and fermentative activity. By stimulating lactate utilizers like Selenomonas and Megasphaera, yeast culture helps maintain a healthy balance in the rumen and increases propionate production, which in turn improves energy efficiency. And by optimizing fiber-digesting bacteria like Ruminococcus and Fibrobacter, we can assure that the cow gets the most from the dry matter she consumes. The objective of feeding dairy cattle a nutritionally balanced diet is to support a rumen environment that maximizes microbial production and growth. Good nutritional management requires a balanced diet that feeds the microorganisms, which in turn produce proteins and acids the cow needs to maintain health and productivity. The cow's rumen ecosystem is a fragile environment and must be cared for just like other critical ecosystems. Like the rainforests present on our planet, the functionality of the rumen is feeding dairy cows for optimum productivity demands a rumen ecology approach. Helping every cow maintain the perfect balance of microbial populations within her rumen ecosystem is the key to dairy nutrition that will sustain our dairies for generations to come.